Okay, this is chapter 2. So chapter 2 is on BJT, bipolar junction transistor. Okay, actually there are many types of transistor. So but in this course there are two transistors that will be covered. So we have two basic types of transistor. So first is bipolar junction transistor, which will be covered in this chapter, chapter 3. And then we have field effect transistor that will be covered in the next chapter. Okay, what is bipolar junction transistor? Bipolar, the word bipolar refers to two polarity. So we have two polarity. So actually it refers to the use of both hole and electron as carrier in the transistor structure. So if we recall back the definition of carrier, carrier is the particle that carry the electric signal. So carrier, it should be a particle with a charge. So we have two types of carriers. First one is negatively charged electron, and the second one is positively charged hole. So the bipolar here means that the current in the transistor is as a result of the movement of both carrier. So this is opposite of certain devices that the current flow inside the device is only due to the either hole or electron movement. So BJT is used in two broad areas or two broad applications. The first one is linear amplifier. So linear amplifier. So usually we amplify the time dependent signal. For example, AC signal or AC waveform. And then the second one is an electronic switch. So electronic switch we have discussed in our I think the early chapter, what is electronic switch. So switching, you can turn on then turn off with the input, and the input is in form of electronic signal, for example current or voltage. So this is electronic switch. Okay, this is the structure of a BJT. So in BJT, in general, most of the BJT is made of silicon. So and then it use the PN junction. So it's similar to the operation of the diode. Okay, so but instead of in the diode, we have the one layer of P type and another layer of N type. But for BJT, we have three layers. Okay, we have N type. For example, in this structure, we have N type emitter, N type layer called emitter, and then at the bottom of the emitter layer, you have P type base, and then at the base we have N type collector. So BJT is constructed with three layers sandwich of alternating doped semiconductor material. So we have three layers, and then both layers will have the alternating doping type. So the middle region is called base, and the remaining two regions, one is called collector, and then another one is called emitter. So the base is at the middle layer with a opposite doping type. Okay, so when we dope the semiconductor, actually we can control the doping level. Okay, what does it mean by doping level is the concentration of the added dopant atom or added impurities. Okay, if we add many dopant atoms, so means that semiconductor is heavily doped. If lightly doped refers to the condition where the doping is done with a small concentration of dopant atoms. Okay, so basically the design of the BJT, this is certain specification for the design in the BJT in order to make the device operate in optimum condition. So in terms of the base region, say here the base region at the middle layer here, usually the base region is made to be very thin and it is lightly doped. So it means that the doping concentration is not so high. It's quite low. And then the emitter doping here, this emitter doping is is heavily doped, but the thickness, in terms of the thickness, this is a moderate thickness. And then the last one, the collector here, this is the collector here, which is the thickest layer, and the doping is moderately doped. Okay, so this is the right figure is the structure of the BJT. But usually in some of the textbook or reference book, we simplify this structure into this very simple box. So we have three blocks, N type, the top one is emitter, and then we have the P type base, and then this one is N type. Okay, so in previous slides I show you the NPN BJT. So NPN BJT is where so since in BJT is made from 3 layers, so with the alternating doping type, so there will be the collector and emitter should have the same doping type, and the base will be different. For the NPN, both collector and emitter is N type, but the base is P type. Okay, actually we can create another BJT. We call it PNP. So PNP is where the collector and emitter is a P-type semiconductor, but the base is N-type. So 2P region separated by N region, which is base. Okay, so in terms of the equivalent circuit, the BJT, if you consider the PN junction as a diode, so you can have the equivalent circuit something like this. So for example, this is anode. Okay, this is anode. So anode is P type, and then this is N type. This is N, and this is P. So this is P and P. So for example, this one is cathode, this is N, and then this is anode, P type, and then this is N. So this is NPN. Okay, and then because we have the 3 layers with alternating doping type, so there are 2 PN junctions formed in the device. So again, what is junction? Junction is actually an interface or the boundary between N-type and the P-type. So we have the first junction is between the base and emitter. So for example here, between base and emitter, we have the boundary here. This is base emitter junction. And the second one is between the base and collector. So this is the collector, we have base collector junction. So the junction is important because the junction will be the one that will control the current flow between the N and P region. Okay, so we have 2 types of BJT, NPN and PNP. So when we want to draw the electronic circuit, the symbol of BJT used as shown in this slide. So the base terminal will be at the middle, and then usually we put collector at the top and emitter at the bottom. Okay, and then to differentiate between emitter and collector, there is an arrow at the emitter. There is an arrow at the emitter. So the arrow actually showing the current direction of the current direction in the device. For example, NPN here is showing the direction outside, exiting the device, so the current will be, emitter current will be downward. Okay, for PNP, the emitter, the arrow direction is toward inside the device. So basically the emitter current, the direction of emitter current is upward. Okay, so and then for the base, we apply this is voltage. Usually this is not usually, most of the time the base current, direction of the base current is defined from left to the right. So this is the direction of the base current. And then at the end of, and then lastly is the collector current. Collector current should follow the direction of the emitter current. So this is the collector current. And then for the PNP, the collector current is facing upward. Okay, so there's a tip how you can remember the symbol of NPN and PNP. So you see, this one is NPN. NPN is not pointing in, so the arrow should pointing out. So this is why pointing out. And PNP is pointing in, so the arrow is pointing in. So this is one of suggested tip how you can remember the symbol of NPN and PNP.